Right, in this video we're going to look at and versus or when we're talking about probability or even like logic. This comes up quite a bit. So and sometimes is called the intersection, and actually this that I'm highlighting in blue is the and symbol. It's an upside down U. That's also called intersection. And for and, both events must be true. So if I said being a boy and a basketball player, both of those things have to be true, being a boy and a basketball player. So like LeBron James would be a classic example of that. If we're talking or is called union, and if I said being a basketball player or a boy, that would mean that any boy would make this true, and any basketball would make this true. So you could be a boy or not a boy, as long as you're a basketball player, that would also make this true. So an example might be Maya Moore. She's a professional basketball player. That would make this true. Or another example might be President Biden. He is a boy. I highly doubt he's a basketball player at this point. But he is a boy, and so that would mean that that statement would be true. But that would, if it was an and situation, then President Biden would not be an example because he's a boy, but he's not a basketball player. Okay, so let's look at some examples here. Hopefully that clarifies things enough. And we'll look at, the first one's going to be rolling 2 dice, and then we'll do another example after this. So it says the example is the sum of rolling 2 dice, and I filled in this chart for you. We have the first die is green and the second die is yellow. And so just so you understand what's happening here, this 10 that I highlighted in red, that means that it was a 6 on the first die and a 4 on the second die. And that's different than this 10, where it's a 4 on the first die and a 6 on the second die. So it may seem a little bit confusing that those are different, but they indeed are different. Okay, so let me get rid of this, and we'll probably come back to doing, we'll do some highlighting here. Okay, what's the probability of rolling a sum of 6 or a sum of 8? So we're looking at all the sums of 6s. We've got all of these, and then the sums of 8s. And since it says or, we just add all of those up. We don't have to worry about where they intersect. It's just look at all that apply and use those. So let's see, we have 1, 2, 3, 4, 5 6s and 5 8s. That's 10 total. And so this would be 10 out of 36. And where I got 36 from is it's a 6x6 grid. And so there are 36 possible outcomes. Just so you see what I'm talking about. There's 6 this way and 6 that way. Okay. So I'm going to erase some stuff. Oops, looks like I can't erase. Oh, shucks. Let's see, there we go. That's what I'm looking for. Okay, back to the next one. What's the probability of rolling a 2 and rolling a sum of 3? So rolling a 2, all of these that I highlighted in gray are rolling 2s. Same thing here. Those are all the ways that you could roll at least 1 2. And then it says, and rolling a sum of 3. So that would be these that I'm highlighting in blue. So we're only looking at the sum of 3s where you're also rolling a 2. Well, the only way to have it happen is if you roll a 2. But anyway, so there's 2 of those out of 36. And so I should probably get in the habit of reducing this. This would be 1/18. It's an ugly 8. Let me fix that. There we go. And this would be 5/18. All right. What's the probability of rolling a 6 or a sum of 5? So let me do some erasing here. There we go. rolling a 6. So I'm going to highlight that in blue. So there's some 6s. There's some 6s. I don't want to highlight this yellow. There we go. So it says rolling a 6 or a sum of 5. So a sum of 5 would be these. Now, because it says or, we just count away. We don't have to worry about the overlap in this situation. So there are, I'm going to highlight again and count as we go. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15 times where that happens out of 36. Hopefully you're kind of getting the hang of this. What I should have encouraged you to do this at the beginning, but I'd really encourage you to pause the video now and see if you can answer the last two, and then, you know, unpause and make sure you got them right. Okay, last two. It says, what's the probability of rolling a 6 and a sum of 5? So rolling a 6 would be this and this again. And then a sum of 5, well, it was the same thing. I probably shouldn't have erased, right? And actually, to make things a little bit easier here, let me highlight the other one in red, a sum of 5. So the sum of 5 I did in red. The rolling a 6 I did in blue. And when it says and, you're looking where do those overlap? So where do those both happen? And these don't overlap. You cannot roll a 6 and have the two dice add up to a 5. And that kind of makes sense. If you have 6 plus something, you can't get 5 unless you're adding -1. And dice don't have a -1 on them. So this would just be 0 out of 36, or you could just write 0. Okay, the last one, what's the probability of rolling a 3 or a sum greater than 7? All right. So let me erase this. Let's start with the 3. Come on, there we go. All right, so rolling a 3, that would be these that I highlighted in blue. And then a sum greater than 7, so I'll do that in red. Let's see, there we go. Okay, so when it says or, we just count all of them. We don't have to worry about where the overlap is. So in this case, I'm not worried about overlap. I'm just worried about where is it highlighted. And this would be, you can hear my dog in the background there. Let's see, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 ways that that could happen. So this would be 22 out of 36, which reduces to 11/18. All right, so that's the first example. If you feel like you got it, then maybe you're good to go. I'm going to do one more example using a Venn diagram. If you're not sure what that symbol means right there that I circled in black, definitely stick around. If you still don't understand what these symbols mean, stick around. All right, so let's get into this. I'll try to go quickly and not waste your time. So this first one says the probability of a college graduate, and then it says this U symbol. And if you remember, this means or. U means or. Upside down U means and. This is called union. This is called intersection. Okay. So college graduate or salary is greater than $80,000 per year. So that would be all things that apply. The or just means everything that applies, and that would be that. So 22% plus 54% plus 8%. And let's see, 22 and 8, that's 30. 30 plus 54 is 84%. Cool. Next one, a college graduate, and then the upside down U is and the salary is greater than 80%. So this is different. It's very, very close, but it's different. So this one says they have to make over $80,000 a year and be a college graduate. The only place that happens is where those two overlap. So this would be 54%. All right. The next one is saying the probability that they're a college graduate with it raised to the C power, it looks like. And what this symbol means is complement. Oops, I forgot to go to the pen. There we go. Complement. Actually, I think it's plement. Complement. There we go. So college grad, complement. So that means everything that's not a college graduate. That's what complement means. So that would be those two. It would be 8 and 16%, which is 24%. Another way you could look at it is you could add up 22 and 54 and do 100% minus 22% minus 54%. And that would get you 24% as well. Okay, the last one, it says, what's the probability? Let me erase some circles here before we do the last one. Once again, I would encourage you to do this, pause it, do it, and then see if you get the same answer. So probability that the salary is less than $80,000. So that has to be anybody who does not make over $80,000 a year. Notice it says less than. So these people are excluded because they make over $80,000 a year. The rest of the people would be considered making this true. So we got 22%, 16%, add that up, we get 38%. Wonderful. All right, so that's it for and or in probability.